In this video, we're learning how to find the distance between 2 points. And if you look at the top of our screen, you're going to see this equation to find the distance. And I will show you guys how we can use that using example 1. And for example 1, we're also going to do it visually just to show you guys where this equation comes from. So for example 1, we want to find the distance between the points -2, -3, and 4, 5. So first what I'm going to do is plot these 2 points. So if I want to plot -2, -3, I'll go over here to -2. I'm going to go down to -3, and I'm going to plot this point. And let's actually plot that in a different color so it's easier to see. And if I want to plot 4, 5, I'm going to go over to the right 4, and I'm going to go up 5, and I'm going to plot my point right here. And now what we're trying to solve for is the distance between these 2 points. So we're trying to solve for this yellow distance, like the length of that line. So what I'm going to do is draw a right triangle using that yellow line as the hypotenuse. So I'm going to draw a right triangle like this. Make the lines a little thicker so it's easier to see. And now we have to think if we remember how to find the side lengths of a right triangle. So what's going to come in handy is the Pythagorean theorem, which I'm going to write over here, which is a squared plus b squared is equal to c squared. And our c in this case is our distance between the 2 points, so I'm going to put that in yellow. So now we have to think, is there any way we can actually find the lengths of a and b in this triangle? And if we look at our coordinate grid, we can just count. So if we look at the bottom leg of our triangle, so this one right here, and we just count how many blocks there are, we'll get that this distance is 6. So we know that that one side is 6. If we do the same thing for this other leg over here, if we count the blocks, we should get a distance or a length of 8. So now we can use these sides to find the hypotenuse, which again is the distance between the 2 points. So we're going to plug it into the Pythagorean theorem. So a squared and b squared, or a and b, are interchangeable. So you could use 6 for a and 8 for b, or 6 for b and 8 for a. It doesn't matter. I'm going to use 6 for a. So I'm going to say 6 squared plus my other leg squared, so 8 squared, has to equal my distance, c squared. And now I'm just going to simplify this and solve. So 6 squared is 36, 8 squared is 64, this is equal to c squared. I'm going to combine 36 plus 64 to get 100. So I have 100 is equal to c squared. And now to get the squared out of the right side, I need to take the square root of both sides. On the left, I get a positive 10 because I can't have a negative distance. And on the right, I am just left with c. So I get that the distance between these 2 points is just 10 units. And now I'm going to show you guys how that relates to this formula that we have up top. So I'm going to rewrite the formula down here. So the formula says that the distance between 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And now we're going to talk about what each of these parts of the equations mean. So x2 minus x1 is really just the difference between the x values, so the change in the x values, right? Which is this line right here. So this is the difference in our x values because it's the horizontal distance between our 2 points. And now this other part of our equation, y2 minus y1, is just the change in our y values because it is the distance between, or the difference between, the y coordinates of our 2 points. It's the vertical distance between the 2 points. So basically, the distance formula comes from the Pythagorean theorem. We square the difference between the x terms, which is like squaring a squared, right? It's the same as 6 squared. And then we square the difference between the y terms, which in this case was 8 squared. And then we have to take the square root of that in the end to figure out what our hypotenuse is. So I'm just going to show you guys how we can plug in our points into this equation in case you guys want to do it the equation way. So I'm just going to label our points with x1, y1, x2, y2, and now we're going to plug it into our distance equation. So d is equal to the square root of x2, which in this case is 4, minus x1 of -2, squared, plus y2, which is 5, minus y1, which is negative 3 squared. And now we're going to simplify. So the square root, and 4 minus negative 2 is really 4 plus 2, which is 6. So square root of 6 squared plus 5 minus negative 3 is the same as 5 plus 3, which is 8. So 8 squared. And you may notice this looks very similar to the Pythagorean theorem we used on the right. And now we're going to continue to simplify. 6 squared is going to give us 36, plus 8 squared, which is 64. We're going to add them together. 36 plus 64 is 100. And if we take the square root of 100, we get that the distance is equal to 10 units. So for the remainder of the video, I'm going to use the formula, but you guys can always graph the 2 points and use the Pythagorean theorem if you think that's easier. So taking a look at example 2, we want to find the distance between the points negative 5, 3 and negative 1, 8. So I'm going to start by labeling my points with x1, y1, and x2, y2. And then I'm going to rewrite my distance formula. So distance is equal to x2 minus x1 squared plus y2 minus y1 squared. And now I'm going to plug in my values. So I have the square root of x2, which in this case is negative 1, minus x1, which is negative 5, squared, plus y2, which is 8, minus y1, which is 3, squared. And now I'm going to continue to simplify. So negative 1 minus negative 5 is the same as negative 1 plus 5 squared, plus 8 minus 3 is 5, so plus 5 squared. And we're just going to continue to simplify this. Negative 1 plus 5 is positive 4, so we have 4 squared plus 5 squared, and now we'll square both of those. 4 squared is 16, plus 5 squared, which is 25. And if we add 16 plus 25, we're going to get 41. So we get our distance is the square root of 41. We can't simplify the square root of 41. It doesn't have a nice whole number square root, and no perfect squares go into it. So we're just going to leave our answer as is. If you want to find out the decimal version or decimal approximation, you can put it in your calculator, but I'm going to leave it as the square root of 41. Taking a look at example 3, we want to find the distance between the points 15, negative 8 and 12, negative 12. So again, I'm going to start by rewriting my distance formula. So I have x2 minus x1 squared plus y2 minus y1 squared, all under a square root. I'm going to label my points x1, y1, x2, y2, and now I'm just going to plug those in. So I have distance is equal to the square root of x2, which is 12, minus x1, which is 15, squared, plus y2, which is negative 12, minus y1, which is negative 8, squared. And now I'm going to simplify. So 12 minus 15 is negative 3, so I have negative 3 squared, plus, we're going to rewrite negative 12 minus negative 8 as negative 12 plus 8, that entire thing squared. I'll keep the negative 3 squared as is for now. I'll simplify it in the next step. You could also simplify it now if you'd like. And we're going to add negative 12 plus 8 to get negative 4. So we have negative 3 squared plus negative 4 squared under the root. Remember, when we square a negative number, it becomes positive. So negative 3 squared is positive 9, plus negative 4 squared, which is positive 16. We're going to add 9 and 16 to get 25 under our root. And the square root of 25 comes out as a nice whole number. So the square root of 25 is just 5. So we get a distance of 5 units. Let's go through a couple more examples just to make sure we've got this down. So for these last 2 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure that you solve them correctly. So for example 4, we want to find the distance between the points 20, 7 and 13, 5. So let's rewrite our distance formula. And I encourage you guys to rewrite the formula as well. I think it'll help you guys memorize it more easily. So we have x2 minus x1 squared plus y2 minus y1 squared. I'm going to label our points x1, y1, x2, y2, and I'm going to start plugging in our values. So x2 in this case is 13 minus x1, which is 20. All of that's going to be squared, plus y2, which is 5, minus y1, which is 7 squared. And now we're going to simplify. So we have the square root. 13 minus 20 is going to give us negative 7. So we have negative 7 squared, plus 5 minus 7 is negative 2. So plus negative 2 squared. We're going to continue to simplify. We have the square root. So negative 7 squared is a positive 49. Negative 2 squared is a positive 4. We're going to add 49 and 4 to get 53 under our root. We can't simplify the square root of 53, so we're going to leave it as is. So we get a distance of the square root of 53. And moving on to our last example, we have the points 2, negative 3 and negative 10, 2. So let's rewrite our formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's label our points with x1, y1, x2, y2, and we're going to plug in our values. So D is equal to the square root of x2, which is negative 10, minus x1, which is 2, squared, plus y2, which is 2, minus y1, which is negative 3, squared. And now let's simplify. So negative 10 minus 2 is negative 12. So we have negative 12 squared. 2 minus negative 3 is the same as 2 plus 3. And 2 plus 3 is 5. So we have 5 squared. And now we're going to square both of those numbers under the root. Negative 12 times negative 12 is positive 144. 5 times 5 is positive 25. So we have 144 plus 25 under our root. If we add 144 and 25, we get 169. And 169 is a perfect square, so we can find the square root, which is 13. So we get a distance of 13 units. So hopefully this video helped you guys learn how to find the distance between 2 points. If you're looking to do extra practice, we've linked a free worksheet in the description of this video, which has tons of problems similar to the ones we went over today. And the nice thing is that there's answers at the end of the worksheet.